Hey there, I'm going to go over the ECDSA node project and show you how to begin on this project. The first thing I want to say before we jump in is that if you've never done web application development before, or if you've never worked in a React app, this may be somewhat unfamiliar and difficult to work through, although I do recommend that you persist because if you get through this project, you'll have a really good understanding of how blockchains work when we dive into week 2. So do your best to dive into the React documentation and try to work through this problem as much as possible. There's not too many client-side changes that you have to make here, so hopefully this is approachable for everyone. So we're going to go ahead and jump into this project here. What you can see is I have cloned this ECDSA node project, and I have this locally inside of my environment, and I am using this inside of VS Code. We recommend you use VS Code as your IDE purely because that's what I'm going to be showing the video in. If you want to use a different IDE, that's totally fine. However, it might be easier to follow along if you use the same one that I'm using. So here I have this README up, and this is going to give me all the instructions for starting the application. Something that you may be unfamiliar with, not coming from web application development, is that we are going to be starting both a client and a server. So if you're not familiar with that, what we're going to do is we're going to open up 2 different terminals, one for the client and one for the server, and we're going to run each process. So that's what I'm going to do here to start this off in the beginning, is I'm going to open up a terminal down here in my VS Code, and I'm going to split this in 2. I'm going to move one into the client folder, and I'm going to move one into the server folder. Then what I'm going to do is I'm going to install the dependencies for each one. Right? That's going to be step 2 for the server and the client. What this is going to do is it's going to go into these folders and use these package.jsons to pull in the dependencies for both the client and the server. So let's go ahead and do that next. We're going to do npm install on the left-hand side and an npm install on the right-hand side. And then we should have all of our dependencies for both the client and the server downloaded. Cool. Once we have that, we can run both the client and the server. The client is going to run using Vite, which is a build tool for web applications. So I'm going to go ahead and use npm run dev here, which is going to run my local application on port 5173. And then I'm going to run node index here for the server, or you could use nodemon, which I do recommend. Nodemon is going to restart the server anytime that there's a change to one of your server files. So I recommend doing nodemon index, which is going to run the server on port 3042, which is what the client is going to be expecting here. If you get that all set up and running, you should be able to go to your local host and be able to see the project running on port 5173. So let me go ahead and explain this UI to you, what is happening here. So on the left-hand side, we can plug in a wallet address. The 3 wallet addresses are defined in the server right now as 0x1. So if you go to the server index.js, you'll see there's an address for 0x1, 0x2, and 0x3. So if I come over here and I type in something like 0x1, you'll see that my balance is 100. Now, if you're familiar with blockchains, this may seem like a silly address, right? Because it's very, very small. We're going to move towards something that would be more like a wallet address on a blockchain like Ethereum. But for the moment, the server just has these short addresses to make it really, really simple, right? So we can look up the balance for 0x1. We could look up the balance for 0x2. We could look up the balance for 0x3. And anything else that's not in our mapping is going to have 0 balance, right? We just have these 3 balances here, which is going to set us up. You can change these if you'd like to kind of test it out and see how that works. And then once you have that set up, what we can do is on the left-hand side, we can choose to transfer something from your wallet here on the left-hand side to another address. So maybe we have a recipient that's like 0xabc, and we want to send them 20, right? If we send them 20, we expect this balance to decrease by 55 for the wallet address. And then for 0xabc, we expect it to increase by 20, right? You can see if I paste in the 0xabc, now I have 20 in there. If I go back to 0x3, my balance is 55. If I refresh this application, those balances are going to stay the same because the server is keeping track of that, right? So if I have 0x3, still going to have 55 in 0x3. 0xabc, I'm going to have 20 in there, right? So the server is keeping track of the balances. So unless we restart the server, those balances are going to remain here for the client. Okay, so what do we want you to do in this application? That's the next step. One thing that you might notice, think to yourself, what is missing here? Like if we were trying to think about this from like what we learned about public key cryptography and how you could use this for security or for being able to sign a message that only you could have possibly signed, that allows you to maybe move some funds or interact with a smart contract when we get to smart contracts. What could you do here with public key cryptography that would make this application better? Currently, this application allows anyone to change these wallet addresses, right? So like if say, or change the balance in the wallet addresses. Let's say like this was, Dan's wallet here, and this was Al's wallet here, and this was Ben's wallet here, right? If we have these wallets that are associated to each user, and then we are trying to figure out, we may want to try to figure out a way where only they can send balances from those addresses, right? At the moment, like if I wanted to and I said like, okay, this is Al's address, we can go in here and we could say 0x2 and we could transfer from Al to me, right? If I'm Dan, I could say 0x1 and I could just transfer out his entire balance, right? And now I own his entire balance. That's not very secure, right? We don't have a way to actually give somebody ownership of an address. With public key cryptography, we can accomplish this. We can make it such that I can give you an address that only you hold the private key to, so that only you can move those funds over. That's the goal of this project, is to get it to a point where it uses public key cryptography so we can give out addresses to specific users and only they can move funds by telling the server that they would like to. So the first step here would be to start to incorporate some of the cryptography that you learned about in the previous tutorials, right? If you recall, we had a tutorial where we went through 4 different stages of public key cryptography, where we learned how to recover keys using a signature, where we learned how to sign messages using the SECP 256K1 curve with a private key, and where we learned to hash that message, right? This Ethereum cryptography library can be really useful for your project, and that's what I recommend you use here in order to incorporate public key cryptography. So if we're going to do that, what I would recommend next is to install Ethereum cryptography, the library, both into your client side and into your server side. So that would be the next steps here. Is we might want to start a new terminal, and we're going to leave those other 2 processes running, the client and the server, right? So they continue to run as we're installing this library. What I want to do is on the front end, so if I go into my client application, I want to install Ethereum cryptography, and then same thing on my server side, right? So I'm going to move into the server side, and I will also install Ethereum cryptography. Cool. So once we have that in both sides, you can see that the package.json has been updated in both of these. And what we could do is we can now use that Ethereum cryptography to do some of these things that we were doing in the tutorial previously. This project is pretty open-ended, so you can do this, you can accomplish this however you'd like. I encourage you to think about Web3 applications that you've used. What is the user experience that you typically get, and what are the expectations that you have as a user? One way to accomplish the goals of this project is to ask the user what their private key is so that you can sign a message and send it to the server. This is the first thing that I'll show you how to do here, but I also encourage you to think about what the downsides of that is. If you gave a private key to a web application, that web application can take your private key and send it to a server somewhere. Now they know your private key and your entire wallet address is compromised, right? So if you could think about a way to solve this challenge by passing in a signature rather than a wallet address, that would be the more secure and preferable way to solve this challenge. But I'll show you the simpler way here, which is to just fill in a private key here first. So let's go ahead and take a look at that. So if we were going to do something where instead of passing in a wallet address, we wanted to pass in a private key, the first thing we might try to do is generate a private key. right? So we learned how to do this, or we have the Ethereum cryptography library in order to be able to do this. You could pull up the documentation of the Ethereum cryptography library, and in it, you're going to find a method that is going to allow you to generate a random key. What I'm going to do is I'm going to put this script that I'm going to write into my server folder because it's going to have the Ethereum cryptography library, and I'm just going to create a new script that's going to allow me to run it once and generate a private key. So let's call this my generate.js, right? I'm going to have a generate.js, and inside of here, I am going to generate some private keys. So I might say, let's say const sccp is equal to, and we can kind of pull this out just very much like we did inside of our lessons from before. And I will make these scripts available for you so it's a little easier to get started. So we can take sccp, and what we could do is we could generate a private key. So we can say our private key is going to be sccp.utils.random private key. This is going to return us a private key. If we want to see this as hexadecimal, which is the typical way that we see private keys, we're also going to need to use utils from Ethereum cryptography, and we can grab that out of here as well. So you may have seen this utils before. It's under Ethereum cryptography utils, and there's a method in there called toHex. You can find this in the documentation if you look up Ethereum cryptography inside of NPM. So let's just go ahead and pull this one over. I'm going to grab the utils, and inside of the utils we can pull out something called toHex. toHex is going to allow us to take the private key, which is coming back as a byte array, and we are going to display it as hexadecimal, which is how we typically see private keys and addresses. We see them in hexadecimal format. So I'm going to go ahead and log this out, private key, and then we're going to say toHex, and we're going to pass in this private key here, right? Cool. So in my server, if I want to run this now, let's kill this terminal over here, and I'm just going to clear this out. In my server, if I want to run this script now, I can run this script by saying node and then scripts/generate.js, and that's going to generate me a private key. Every time I run this, it's going to generate me a new private key, right? Some of those look pretty similar, but that's pure just luck. These are random private keys. A couple of them start with 97, which is interesting, but they are random. So we are getting random private keys each time. Something else we might want to do with these private keys is we might want to get the public key. The public key could be the representation. It could be the address, the thing where you can actually send some, funds to somebody, and only they control it by signing a message with their private key, right? So if we want to get the public key, there is a method for this as well, where we could say public key, and then we could do is equal to scp, let's see, get public key, and then we could pass in the private key here, and that will get us the public key. And we could do the same thing where we take the public key is going to be toHex, pass in the public key like that, and we should be able to see that there as well. So here is our public key, here is our private key. So in these lessons, you may have learned on the fourth stage that in Ethereum, the way that the address is displayed is just the last 20 bytes of the Keccak hash of the public key. You could choose to do this just like Ethereum does, where you take the addresses as the Keccak hash of the public key, or if you want, and this is totally fine, you could take the public key and this could be your address. So what we could do now is in the server, we can give these like better addresses, right? Now we're starting to use public key cryptography. We could give these addresses like this. That could be mine, right? And I'll control it with this private key. Let's pretend like you don't know what that private key is. If I'm the only one who has that private key, I am the one who controls this public key right here, right? I could generate another one, and this could be Al's in this case. And I could generate another one, and this could be Ben's in this case, right? So we have 3 public keys. 3 balances, and if we take these into the client side, now we should see that it should be updated. Let's refresh, and you can see now this public key has a balance of 100. If you're seeing this public key as just being super, super long for an address and you want to change this into the Ketchak hash last 20 bytes, I totally recommend you do that. This project is open-ended. Please experiment with this as much as you like. Definitely would rather see something more equivalent to Ethereum where you take the last 20 bytes of the address. But this is totally fine too. If you want to leave it as the full public key, that is totally okay. So you can see that we have these public keys. Now we could transfer between them. So maybe, if we want to transfer from that address to this address and we want to pass in 50, now we lose 50 from this one and this one gains 50. So now it has 100 because it started out with 50, as you can see over here. Okay, so we haven't done that much yet, right? Because if you look at this, we still haven't implemented signatures. We have changed it so the addresses are public keys, but that doesn't necessarily mean that we've implemented any sort of security here using public key cryptography. If we wanted to implement some security around public key cryptography, what we would need to do is we would need to sign some sort of an intention on the client side. We would need to sign some sort of a message, a transaction of sorts that would be sent to the server. And then the server would then say, okay, I'm going to recover from that signature the person who sent this, the address of the person who sent this. Once they recover that public key or that address, then the server can say, oh, okay, this is the only person who could have possibly sent this message. And so therefore, I know it's authorized, right? That's what we need to implement here in the client side, is we need to implement some sort of signature. So I'm going to start in the direction of what you might need to do here just to get you going. And then I want you to take it from wherever I leave off here. So the first thing is what we might need to do. And let me just also say that you could do this multiple different ways, right? We could make this input field either a wallet address. We could change this from either being a private key, or we could change it to be a signature, right? A signature would be much more secure because you are doing all of you're doing the signing out of the client application, so the client application doesn't get a hold of your private key. If a website that is a legitimate Web3 application ever asks for your private key, don't put it in there, right? Because as soon as a website has your private key, they can send it to a server somewhere and then you are compromised, right? So a really good user experience here would be not to put the private key in the browser, but that's the easier thing to do for this particular project. So if you want to go in that direction, that's totally fine. Let's look at what that would be like. We're going to take this wallet address. Instead of making it wallet address, we're going to make it a private key. So let's go ahead and do that on the front end. So on the front end, you're going to see here that the top level component app.jsx is going to have two things in it. It's going to have the wallet and it's going to have the transfer. And if you want to know how these break up, we could just remove some of this stuff just to break it and see what happens. If I get rid of the wallet side is gone, the left-hand side, right? If I get rid of the transfer, the right-hand side is gone, right? So you can see it's broken up into the left-hand side and the right-hand side. We put these back and we're going to have both there, the wallet and the transaction. Now, something that's really important to notice here is that these two share some state. The wallet is going to be the one where you set the address that is the person sending the funds to the recipient, right? So we need to share this state between these two components. So we have the app creating the state and then passing it down into these two children components here, right? So the balance is being set and passed into the wallet, and then the transfer is also has the ability to set the balance. The address is set in the wallet, and then it can also reset the address. So what we're going to want to do to change this a little bit is we're going to want to make this, we're going to want to add the ability to put a private key in here, right? So I'm going to do, let's do a private key, and we'll do a set private key. And we'll do an empty string, that's totally fine. We'll pass this into the wallet, and we'll do set private key in here as well. And then the transfer function is going to take the private key eventually. Maybe we don't do it just yet, But the transfer function should eventually take the private key, because what is it going to do with the private key? It's going to generate a transaction, a signed transaction, a signature, right? So that way the server can then check, the server can then take that signature and it can derive the address for the person who sent this message. So you don't have to send the private key to the server, right? That would be very insecure to do that. You only have to send the signature through. We can even generate the signature offline, which would be the preferable method, pass the signature through the client, and then the server gets the signature and recovers the address then, right? So let's go ahead and dive into this wallet. It's going to take this private key and set private key method. So let's take these things in here. We'll take the private key and we'll take the set private key method. And what we're going to do is we are also going to include SECP256K1, the Ethereum cryptography library, on the front end, as well as the back end, right? Because we're going to want to do some crypto on both sides. So, okay, so first off, this address right here, we're going to change this to be the private key. And we're going to ask the user to input the private key. Again, like I said, in a real live production app, never do this, right? The user shouldn't input the private key. Typically what you have in Web3 applications is you have something like MetaMask or a wallet browser where you can sign a message, and then MetaMask holds onto your private key and it only hands the signature off to the server and to the client, right? So that way the client never knows your private key, so it never becomes compromised by anything else. The thing that holds onto it is your MetaMask. Or if you're connecting MetaMask through a hardware wallet, it never leaves the hardware wallet. Cool. So for the private key, let's go ahead and say type in a private key. We're changing the label. We're also going to change this value to be the private key. And then it's going to call this on change whenever it changes. This on change is now not going to change the address. It's going to change the private key. So the private key is going to be this. And with that, what we're going to want to do is we're also going to want to derive the address. In this case, we're just going to make the address the public key. But again, like I said, if you want to make it the Ethereum address and take off that last 20 bytes, that's even better, right? So let's go ahead and set the address, or set the private key, right? So we're going to set the private key right here. And just to make sure that that's working, let's just come over here and paste in a private key and make sure that that's updating properly. Okay, that looks to be updating properly. So the next thing that we're going to want to do is we're going to want to derive the address from the private key. And we know how to do this because we've done a little bit of this crypto before in the previous tutorial, right? So in order to derive the address, what we're going to do is we're going to get the public key from the private key. So what is our public key in this case? We did this on the back end, right? Once we were given a private key, we could put it into this SECP get public key method, and then we could derive our public key, which is in this case our address, right? So let's get the public key. We'll call it our address because that's what we're using it as, and we'll say we'll plug in that private key there. Now, one thing we do need to do is we need to get this SECP. Remember, we installed this on the front end. So what I'm going to do is I'm going to say import star as SECP. One thing that may be kind of confusing if you're not used to this is JavaScript has evolved both in the browser and server side. So you're going to see two different import syntaxes. On the front end, you're going to see this import from, and on the back end, you're going to see require. So just something to note there that you may need to keep track of. So in this case, we're going to say import star as SCCP from Ethereum cryptography / SCCP 256K1. And we're going to go ahead and use that to grab that address. And then we're going to set the address like this. Now, if we want to make sure that we are actually getting this address properly, what we should do is we should display this out on the page, right? So let's just make sure we're getting that address properly. We're taking the private key. The private key is then being translated into the public key, and then that should set the address on the page. If that's all working properly, we should see the address that we expect. So for this private key, we should see this public key, right? So if I type in that private key, Oh, something went wrong. Let's see if we have a console error. Maybe something I did there. Set private key is not a function. That's interesting. Set private key. Maybe you guys saw this. I forgot to save my app.jsx. You know, these types of things always happen. All right, cool. So let's go ahead and plug in our private key again and see what happens here. Okay, so there's an address there. It's 499. Well, that's not the one I expect. 499. You know why that doesn't look right? Because I didn't translate this over to hex. So let's just make sure that we translate this over to hex before we display it. So this, once we get the address back from the private key, we're going to want to do the same thing that we did on the back end, which is we're going to want to import that 2 hex from Ethereum cryptography /utils. And then we're going to want to change this address to be the 2 hex address. Maybe we'll do it here. So it's actually in the address variable. We'll do it when we pull it out of the private key, because we're going to want to pass that up to the server as the hexadecimal version. So maybe now it should be the same one. So this private key should generate this public key on the front end as well. So let's see if that works. 046E3C. 046E3. Okay, great. But you'll notice the address kind of messed up the UI here because it's so big, right? Maybe we just want to make that a little bit smaller. So let's just slice the first 10 characters here. So like 0 to 10, and we'll put like a ... there or something like this. These are the types of things I recommend you guys make an even better UI than the one that I'm currently making. So what do we have now? We have a private key that then generates this address, and then we can still send these funds between these different addresses, right? So I have this private key that generates this address, and then I could send some amount, 25, to a different recipient. And in that case, I would want to make the recipient not the private key, but the public key, right? So I could still send it to someone like Al over here and be able to send some funds their way, right? And then if we take this person's private key, which is this one right here that I generated, we should be able to see how many funds they have here, right? Did I take the public key? Whoops. Take the public key. Take the private key. So that generated 04EA, which looks like the right one. Surprised they have no funds. I thought we transferred some funds over to them. Let's try this again. I'm going to try this private key over here, and it's going to have some funds that we're going to send over to the recipient. The recipient in this case is going to be this person here. Let's just send 25 over to them. Okay, we sent 25. And then we will plug in their private key. That should give us the address. The balance doesn't seem to be looking up properly there, because the address is correct, but we do not seem to be. So if we take a look at this get query over here to see what we're getting back on the other side, we're getting a balance of 0, even though we're sending through what looks to be the correct address here. All right. Oh, you know what's missing? What? That's interesting. So on my server side, I accidentally put a 0x here in front for some reason. I don't know where I grabbed that from. I must have forgotten to take that 0x off there. So that's something to be really careful of too. If you have that 0x is just supposed to show you that this is a hexadecimal value. In a lot of cases, when you're doing raw cryptography like this, you'll find yourself tripped up when you're trying to compare two things that one has a 0x and one doesn't have it. Sometimes you really just have to chop that off, and sometimes you want to leave it. So it's just something to watch out for. So in this case, that threw me off. If we restart this process, now that I saved this, the server restarted. So all of our balances are going to be restarted. So this first one is going to have 100 balance, right? So if we go back over here, we'll see that they have 100 balance. This second one should now have 50. And if we plug that in, again, we're not getting that 50, so something went wrong here. Is this public key correct? Oh, there was an extra 2 at the end there too. Oh man. We'll have to go back through the video and see how I got that wrong. And then we'll take the private key. We'll plug it in there. Restart this out. There it is, 50. Cool. So a couple things that could be done wrong here. Be really, really careful with the way that you plug these things in. The next step for you to accomplish going through here is to make it so that you can send a transaction, a signed transaction, to the server, and the server should recover the public key from that signature and only allow the transfer to go through if it recovers a valid public key that actually has those funds, right? So back here inside of the send method on the server, I'm inside of the server and then index.js. What you're going to want to do is back here, you're going to want to get a signature from the client-side application, recover the public address from the signature, and then that is going to be your sender. You don't want to allow the client to set the sender, because that's the main security issue that we're trying to fix here, is that anyone can send anyone's funds. But instead, if we derive the address from the signature, we know that that signature could have only originated from the person with the private key. I want you to think about a few things that may be security holes in the way that you're setting these things up. And we're going to talk about this when we do a wrap-up video later. So best of luck on this. Like I said, it's a difficult project, but if you get in here, get your hands dirty, you're going to be thinking a lot about private key, public key security. And it's also going to get you to think about, how does this actually work in blockchains? Because this server right here is very similar to what happens when you actually send a transaction to an Ethereum node. The Ethereum node has to rederive that address, and that's how it knows that, okay, I can send Ether from this account, or this account actually wants to interact with this smart contract. Okay, best of luck.